Hello everyone, welcome to our new video on object-oriented programming. In our previous video, we have learned the basic idea of object-oriented programming, the drawbacks of procedural programming, so that for that reason we have to use the object-oriented programming and the basic idea and the features of object-oriented programming. And also we have learned the basic concept of object-oriented programming like data abstraction, polymorphism, encapsulation, inheritance, objects and classes. Now in this video we are going to discuss these concepts in a little details to understand their meaning. So let's start the video. Now as we know that the object oriented programming is based on the objects where objects represent an entity that can store the data and has its interface through functions. So the objects is the basic element of object oriented programming. For example, let us look at some real world entities or objects around us like trees, animals, birds. All are the example of object. Each object has its own set of characteristics and behavior. So by definition, we can say that object is an identifiable entity with some characteristics and behaviors. While implementing this program, while implementing the program, these characteristics can be treated as the data members and behaviors can be treated as methods or member functions. Let us consider, for example, consider a plant. So what will be the characteristics? The characteristics will be the name of the plant, color, its leaves, its types, flowering or non-flowering plant and so on. And the behavior will be producing flowers, producing fruits and so on. Now similarly, for example, suppose car. Obviously car is a real world entity. So we can take the example of an object as a car. So what will be the characteristics? The characteristics that will be the model of the car, the number of doors in the car, the engine size, the manufacturer of the car. And what will be the actions? The actions will be its behavior. The actions will be that how to accelerate the car, how to stop the car, how to turn the car, how to brake while the driving. So these are the basics, characteristics and behaviors that are implied on an object. So an object in object oriented programming that comprises data and the code that operate on that data. So to implement that code, we use that methods. In other words, we can say that an object can be defined as a group of data members or attributes as characteristics and related methods, routines or member function as behaviors. So always objects that is called the instance and one particular object is called that instance. And obviously we can create many objects that must have the same characteristics or some defined characteristics. So if we create, for example, multiple objects of car, then obviously the model must be different in that case. The manufacturer must be different. The engine size must be different. But some characteristics and behaviors, they remains same for that objects. And for that object, for example, car must have a common properties and common behaviors. Now we have learned about objects. So what happens if we have more than one objects having the common behavior and common characteristics? So we group together and form a unit. That unit is called as class. So class is a group of objects that share common characteristics and behavior. So far we have taken the example of plants as objects. So the plant is an object and it belongs to the living things class. So this is the class living things. Let us take another example. Consider an animal. One way to visualize an animal is through its species, color, weight, height, and so forth. Another way is to think about what it does. It moves, what it eats, and what it produces, sounds, and so on. So, therefore, we can treat it that the class of an animal that binds various attributes and function together into a single collection that is called an object. A program can contain number of classes and a class can contain multiple objects. So classes are the blueprint or a set of instructions to build a specific type object. Now for example, as we have taken that the car, one particular car we are treating as the object. Now the class of a car that contain multiple objects having the common characteristics like model, behavior, model, brand, its color, they are the common characteristics and must have the some common methods like the size of the car, the speed of the car, how to accelerate the car. So these are the common characteristics and behavior must exist with that respective class, and the class can have multiple objects. Now this is the important thing that we have to remember, the difference between class and objects. Obviously object is the instance that has been taken from a class. A class can have multiple objects. So we say that class is the blueprint from which the objects are created. And the object is that instance of a class. Objects obviously are real world entity such as a car, a pencil, a table, a chair, a bird, all are real world entity. But class, it's a logical entity. It is a group of similar objects. So when similar objects grouped together and form a single unit, we name that unit a class. So class is the logical entity, whereas object is the physical entity. So while doing the program, while implementing the object or class in the program, obviously the object allocates the memory when it is created, and the class doesn't allocate the memory when it is created. Now, let us learn the concept of data abstraction. Well, according to the definition, abstraction refers to the act of representing essential features without including the background details or explanation. Abstraction is the concept of simplifying a real world concept into its essential elements. Now, to understand this concept, let us take an example. Suppose you are driving a car. The thing you only need to know the essential features to drive a car, like how to handle the gear, how to handle the steer, how to use of the clutch, how to use the accelerator and brakes. But while driving, do you get into the internal details of the car, like the wiring of the car, how the motor works of the car? The answer is no. You just change the gear or apply the brakes. But you don't need to know how the mechanism works, how it happens. So, what is happening inside is hidden from you. This is the abstraction, where you only know the essential things to drive a car without including the background details or the explanation. Take another example of switchboard. You only press certain switches according to your requirement. So, what is happening inside? How it is happening? You don't need to know. This is the abstraction. You only know the essential things to operate on switchboard without knowing the background details of the switchboard. So, if we implement the data abstraction, it reduces the complexity and increases the productivity of the algorithm of the program. The abstraction can change the internal implementation of the class independently without affecting the user. The user is working with the essential features. No need to know the exact details that how to implement, how this works. It helps to increase the security of an application or the program as the only important details are provided to the users. So the users that are using that applications, they only need to know how to work with that applications. They don't need to know that how the applications has been created. So this is the concept that reduces the complexity and increases the productivity. Let's come to our next concept, a very important concept, data encapsulation. The wrapping up of data and the functions that operate on that data into a single unit. That unit is called as class, is known as encapsulation. So encapsulation is the most fundamental concept of object oriented programming. It is the way of combining both data and the functions that operate on the data inside in a single unit. We name that unit as a class. The only way to access the data is provided by the functions that are combining along with the data. These functions are called member functions or methods. The data cannot be accessed directly. Obviously, we cannot access the data directly. If we want to read a data item in an object, also called the instance of a class, we have to call a member function in the object. It will read the item and returns the value to you. You cannot access the data directly. So obviously encapsulation that provide us the security of data hiding. The data is hidden, so it is safe from accidental alteration. The data and its function are said to be encapsulated into a single entity. Now, suppose consider an analogy to encapsulation. Suppose for a company, there are so many departments like sales, accounts, payroll, purchase, etc. Each department has its own personnel that maintain its data. Suppose an employee in the production department wants to know how much raw material has been purchased for the next month. The production department employee wouldn't be allowed to himself go through the purchase department data files. Rather, he will have to issue a memo to the purchase requesting for the required information. Then some employee of the purchase department will go through the purchase data files and send the reply with the asked information. This practice ensures that the data is accessed accurately and that it is not corrupted by the outsiders. Therefore, we can say that the department data and the department employees are encapsulated into a single entity, the department. Similarly, the purchase data and the purchase employees are encapsulated into a single entity called the purchase. So the encapsulation, which is closely related to data hiding, it allows the binding of code and the data together and restricts any outside entity from misusing them. Now we have two terms that we have learned so far: data abstraction and encapsulation. The classes use the concept of data abstraction. They are known as abstract data type or simply ADT. The data types, because this can be used to create the objects on its own type. And encapsulation is a way to implement data abstraction which hides the details of the implementation of an object. So abstraction and encapsulation are complementary concepts. Abstraction focuses on the observable behavior of an object, while encapsulation focuses on the implementation that gives rises to the behavior. Encapsulation is most often achieved through information hiding, which is the process of hiding all the secrets of an object that do not contribute to its essential characteristics. The structure of an object is hidden as well as the implementation of its methods. Only the essential characteristics of the objects are visible. In the example that we have discussed so far of departments, for example, the essential information of departments are visible, like the department name, the department head, the number of employees, etc. But the secret information, which is not essential, like the department profit and loss, the of the department, etc., they that are the essential information and that remains hidden. This information is made available only if the request is made through a proper channel. That was in that example issuing a memo or request. So this is how we can implement these concepts in the program while doing the object oriented programming. So thanks for watching this video. If you like the video, then hit the like button, and if you're new to this channel, then subscribe the channel and hit the notification bell icon for regular updates. Thank you.